There we go. Hey everybody, Adam Savage here in my cave with a lathe fix today. So let's just talk about lathes for a second. Lathes, L-A-T-H-E, are one of my favorite tools in the whole world because a lathe is maybe one of the only tools in the world that can build itself completely. It is an inception of a tool. And lathes come in many different form factors. This is a 15 by 40 tool room lathe, which means it has a maximum diameter of 15 inches it can handle at the spindle here and 40 inches wide on the bench. Every lathe has the same constituent parts for the most part. A spindle for work holding. There are multiple ways to hold on to the work. A tailstock for stabilizing the work that's held in the spindle. And a tool holder that sometimes goes on a cross feed, sometimes on a static thing, with which I can affect the material in here. Now, there are lots of different things I can do with the tailstock. I can drill with it, but perhaps the most common thing I do with it is I use what's called a live center. So I'll chuck a piece of work in here, and the live center will chuck here into the tailstock. I should explain the difference. I should explain. These are both centers. This one is live and this one is dead. And the difference is that this one spins on a very nice bearing and this one doesn't. Both work. This is works a little bit better for putting more pressure and holding your work more stably. And my issue today, is actually, let's bring out all the live centers. Okay, so my issue is I have multiple different kinds of live centers for holding on to different kinds of work. I've got this one, which is a live center, and it spins, this big bull nose. And this is for being able to, if I'm lathing something large and hollow, this is a way for me to center on up to a 5-inch hole. So that's my biggest one. And I have used it more than I thought I would. This is my second biggest one, and this actually has a bunch of different pieces that can go up here. This is sort of my bread and butter live center. And this is kind of like a little bit of a clutch live center. It gives me a little more, you can see that it's a little longer and a little thinner, and it gives me a little more room for my tools out at the end where I hold on, where I'm putting the live center. The issue I have, it's a really interesting one, is that the back, all right, so the live center sits in the tailstock in a taper. A taper is a cylinder that is wider at one end than the other. And within machining, there are standard tapers. And Morse taper is one of the most standard. And this is a Morse taper number 4, MT-4, or MT4 is what it's known as. And when you put a live center into the tailstock, you activate it and bring it up, and the pressure makes the taper marry with the spindle taper, right? They grab really, really positively. It's why we use this system for lathes. It is a great positive grab yet removable system for concentricity, for turning to center with a high degree of accuracy. Now, when I want to remove this live center, I bring the tailstock. The kind of standard way to do it is to bring the tailstock all the way back. And actually, I want to get you a close-up of that. So here's my live center. Its taper goes into the spindle taper and joins up. Now, just that little bit of pressure stops it from coming out, which is great. Then I feed it into the work. Now, once I've fed it into the work, how do I remove it? I mean, even just that little bit of grab means that it's grabbing. So what you do is you pull the tailstock all the way back. And if you look really close here, you'll watch it happen. At a certain point, there we go. See that? See how those two just separated?
That's because there's this little extra like 1/8 of an inch on the end of this that bumps into a nut inside the taper and allows the live center to be released.
The issue that I have is that my clutch live center, which gives me a little more room to activate and to work with my tooling, its base here is, it's just the tiniest bit shorter than it needs to be, like about 1/8 of an inch. About 1/8 of an inch. And so today's one-day build, if I choose to accept it, is to increase, just add 1/8 of an inch back here so that this functions the same way as all the other centers do, all the other tapers in my lathe tailstock stock do. So we're going to bring this over to the workbench and start taking it apart and see if I can't. My initial thought is that this is to pull this and remake it just a little thicker. That's my initial thought. We'll see if I can actually do that. All right. Big screwdriver. Let's see if I can. Oh, yes, I can. All right. Oi, 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 oi. It's a big thing. Oh. Here is the part in question. All right. So this is the back of the deal, and you can see it spins and it's got some grease in there, and the grease looks nice and clean. There's no movement on this, so I don't think there's any percentage in me taking this thing entirely apart. So I'm just going to tape up the grease, exposed grease, so that it does not leak anywhere. I'm going to store it over here, just off to the side. And then I'm going to take a look at this guy here. Okay. So I have a pitch gauge here. I'm going to figure out what the pitch of these threads are. All right, it's more than 20. 26 threads per inch. Okay. 26 threads per inch. All right. So what I've got here is a plug that I want to replicate. I want to replicate that. I want to replicate that topography, this distance from the shoulder to the ends of the threads, the exact diameter of the threads, and then I want to make this part, this part here, 1/8 of an inch thicker. And I've got this lovely piece of steel to use for this. And so we're going to chuck it in. I don't need perfect concentricity on this piece, so I don't have to worry about run out, really at all. So I'm just going to crack this open, pop this in. Nice, like that. Okay, so now we're going to just turn it down, a rough turn down. Oh, I want to make some notes. Okay, so. .35. And then the diameter, the outside diameter,
main OD is 0.1 minus 20 thou. OOD equals 0.98. Is that right? 0.98, yep. Okay. Oh, right. And the whole depth of the thing. We can say points. Oh, right. It's going to be not 0.6. It's going to be 0.725. Yeah, 0.725. Oh, right. First, I want to clean it up. Yeah, 1.125. So I want to take 125 thou right off of that. Okay, so now I want to bring the OD here down to 0.9, and right now it's 0.98, so I want to take it down by 80 thousandths. Take it down by 40 to begin. Okay, that's 40 thou. We're going to take it down another 40 thou. Yep, there we go. I have myself a few thou to play with, which I wanted. Let's, all right. All right, so now it is time to cut the 26 threads per inch that will match the plug I'm trying to replicate here. And to do that on a lathe of this nature, things of that nature, is to actually go to the lathe chart, the TPI chart, and we are looking at inches, 26, and this would be LB8P. LB8P. So we want X, LB8P, B, P, X, 8. L, B, 8, P, X. So we're just going to do a double check on this. Right, so in order to do this, I go from that cutter to a 60-degree thread cutter. Yeah, that's the one. Okay.
this new thread cutter. It is super beefy. And that is a 60-degree. Yeah, okay, so let me get this out. Here, let me, yeah. This. A note about new users of a lathe. There are two engagements of a crossfeed on a lot of lathes. One is for doing a smooth finish pass, and the other is for doing threads per inch, and they're labeled. And the reason I'm bringing up that there are two is because new users of a lathe can be ignorant of the knowledge that this thread per inch can move quite fast. Like if you set it at like 8 threads per inch and you put this thing on fast, it is gonna, whoa, this cross carriage is gonna move at a crazy speed. And I crashed Jamie's lathe back in 1993. Don't tell him. But I crashed Jamie's lathe back in 1993 doing exactly that. Luckily, misery loves company, so does stupidity. I had checked notes with Kristen Risto, who was working. Kristen was like, I did the same thing. And I was like, yes, I'm not the only one. Anyway, just be cognizant that the first thing you should do when checking your TPI feed, your thread per inch feed on a lathe, is away from the work, set it up, and engage. Now you see it's engaging down here. And that should be giving me 26 threads per inch. So I'm going to bring it over here. Just get a little bit of smoothness on this thing so I can see it a little better. So let's speed it up. I'm also going to hit it with Sharpie. I'm hitting with Sharpie because your first thing you do with when you're just testing out your thread cutter is you do a pass, a beauty pass, just to see that you're actually cutting the TPI you want to be cutting. All right, let's see here. So now we're going to we're just going to engage. There we go. And we're just going to double check that. That's not it. It's not 26 threads per inch. It's something else. All right, so I think this may be metric. Let's just double check this. Yeah, that is a 1.0 metric thread. Okay, so I have different charts here then. 1.0 metric, there we go, LP7Z. LP7Z. Yep, right, okay. LP7ZC. Okay. All right. Well, I've gotten to a phase here where 26 TPI and 1.0 millimeter TPI doesn't seem to work. However, I have an idea about making this work, so I'm just going to try it. What I'm going to do is, actually, I'll show it to you. So it repeatedly engages really well for a few threads and then starts to lock up. So what I'm going to do is I'm actually going to come in here and I'm only going to engage the, I'm going to cut out about half of these threads to limit the amount of engagement. Again, this isn't a huge mechanically important piece. I just need to bore out that little hole in the center here, and the measurements are identical. So it's going to hold the bearings in exactly as I want them to hold the bearings in. It's just going to give me a little bit more of a for getting this back out later. Yeah. So, yeah, let's do that. Let's see if I succeeded. Shall we?
Shall we? Try to play a game.
Yep, there we go. And that locks in nicely. Okay, good. I solved that problem. Those are a little looser than I would like them to be, but that is fine. That is fine. Okay, so the depth here is 0.35. Yep. Depth here is dead on. So now the depth here is 0.25, and I want it thicker by, I want it 0.375. 3.74. Full 1/8 inch of extra. Yep, look at that. And that's right where that is. So let us come back over here. We are almost there. So this is what I started to replicate, and I wanted a fatter head on it, fatter by 1/8 of an inch, and that's, I think, what I've got there. Actually, it's fat by a fair bit more than 1/8 of an inch. Okay, so the next step of this is actually to cut this notch in there. However, I'm going to do an operational test fed into the tailstock and just make sure that I'm happy with how everything seems to be operating. So there we go. That new piece goes in there. It's got a bigger depth. We'll see if it goes in. That locks beautifully, and hey, totally works. So it properly holds in the bearing arrangement in there, seals it from dirt and dust, and provides enough of extra. So now, okay, good. I'm very happy. It's rare that I make perfect replicas of steel parts that have to function identically. It's exciting. So to the mill, where I'm going to cut this slot with a slitting saw. Let's see here. So the setup is everything here. Out. Right. There. Yeah, those are identical, so it should be. It should be that if we have The overall measurement is 0.99. Okay, we're going to get at the hammer gauge. We're going to first make sure that this thing is vertical. Ooh, hey, sorry about that. Do. There we go. In. Okay. Okay, right. So I want to measure in top dead center, which means I want to measure the center between these two blocks, really. There's 1, 0. And there's another 0. And we're going to do 1/2 of that as 1/8. Great. All right, so out. Oh, right. Out. And all right, that's the slitting saw I'm going to use. In. And okay, so that is split exactly at the half edge. And now the diameter, which is, what is 1/2 of 0.989?
Half of 989 1/1000ths is 0.4945.
All right, that looks really nice. Go. That looks nice and centered. So, just going to take off about a few thou at a time. I like it. I like it. Ooh. Come on. There you go. Come on. That's it. Ooh. Come on. Can you see? Look at how pretty. Oh, come on.
There you go. That's it. Pretty good. Yeah, I'm going to clean it up, make it look nicer. Okay, I feel like a proper machinist today. This is very exciting. So to recap our build, we had a live center on my lathe that was having trouble kicking itself out of its taper because its end cap was just a little too anemic. So I wanted to take this end cap, which is responsible, hold on, for holding on to bearings, right? So this whole shaft is full of a bearing stack that keeps this spindle really nice. It turns smooth. I hear no crunchy in there. There's no reason I want to pull this apart at all. And I don't even think I need to. So I just wanted to remake an end cap, which had all the same topography, except this top part that stuck above was a little bit thicker. And there she blows. Look at that. Oh, I mean, this is just... All right, so to recap, there was what we wanted to replicate today, and here is what we replicated today. I couldn't be happier with that. The slots are the same size. This one's a little bit deeper, which is fine. I think it looks really pretty. And I'm really, really happy with that. Functionally very, very close. I don't think it should inhibit the operation of this thing at all. So I think we can join these together in holy matrimony. And we can hold on. Dun, 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 dun. Dudes, look at that. I've got a new live center on life. A new lease on life. Woohoo! We'll just do a double check of the operation. Yep. There we go. And it kicks it back out. It does! Woohoo! Woohoo! Lathe miscellaneous shit. That's where this goes. Don't throw anything away. I went into lathe miscellaneous shit drawer, which is right there. Thank you guys. I've been meaning to get to that literally for months and months and months. And today I just thought, it'd be really nice to machine a chunk of mild steel into a useful piece. And thus I did. See you guys next time. Hey guys, Adam Savage from Tested here. If you've ever seen the 6-inch ruler in inches and centimeters on my forearm and wanted one of your own, but you didn't want it to be permanent, well, today's your lucky day. You can now buy temporary tattoos of my measuring stick, my measuring forearm, at tested-store.com. Comes like this, goes on in about 30 seconds with a little water. The instructions are on the back. It comes off with rubbing alcohol, and hopefully it warms you up to the idea of permanently attaching a measuring device to your body, because I use mine every single day.